say I have a series and I want to represent that I want it added together. So this is a to the n is equal to n, which is equal to this. So I have this series. I want to represent that I want it all added together. What do I use to represent that? And that's where this summation notation is. This Greek letter sigma means add it all together. And it has two numbers. It has a top and a bottom number. The top number represents the stopping point. The bottom number represents the starting point. And whatever lies to the right of the summation notation is what is going to be added together. So for this series right here, if I wanted to represent this in summation notation from 1 to 5, what I just did, I would write it like this. Well, I'm not very good at drawing, but so k is equal to 1. And k just happens to replace n in the sigma notations. Honestly, I usually just put n there anyways. But anyways, that's just something not really that important. So I start at 1, end at 5, and, well, I'll just be technical about it. I'll put the k there. So this is the formula. What it's saying is replace k with 1 to 5, add them all together. So what this means is 1 plus 2 plus 3 plus 4 plus 5, and this is equal to 15. Now I don't necessarily have to always start at 1. I can start at 3 if I wanted to. Let's say I had a different series to use 1 over n, and I want to know what its total is between 3 and 7. I would represent that like this. 7, 3, 1 over n, which would be equal to 1 over 3 plus 1 over 4 plus... and that is equal to something I don't feel like doing. But that's how it would be written. And there are a couple simple properties to these summation notations. And here are 4 written right here. The first case is when there is a constant multiplying my k or my n. What would happen if that were to occur? Well, what this says is that this constant is just distributed to all of the terms. So if I go back to my example where I have the summation of k, and let's say it was being multiplied by a constant of 2, then I would have 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5, and it's pretty easy to see that it's going to be equal to 30 instead of 15. I was about to write 15 again, but I caught myself. So that's that. If I have a situation where I have the summation of 2 different things, I can break those apart and then write them as 2 separate summations. So for example, back to these 2 previous examples, if I had something like the sum of, and I'm not going to bother with the k's and whatnot, well, I'll just put k there. Let's see, k plus 1 over k. So the summation of these 2 things, this can be written as, well, let me put the parentheses around just to make sure that it's understood that these are one entity. So according to these properties, it can be written as this. It's 2 separate summations. Summation of k plus the summation of 1 over k. And it will be equal to the same thing. And subtraction is pretty self-explanatory. And the last one is I have the ability to break my summation into two separate entities as far as the start and stop points. And right now that might not make a lot of sense why I would want to do that, but later on when I'm doing integration, it's going to be very important. So for now, let me just demonstrate what this means. I guess let me just take this example right here, the 7 to 3 one. What this is saying is I could break it. I can manipulate my summation. So I've got the summation from 7 to 3, 1 over k. What this is saying is that I can write it like this. Now, in the beginning, there probably aren't going to be any uses at all for this, but as I said, later on, it will become much more important. So I can write this as 7 summation 1 over k 1, and then what I can do is just subtract the other part. So I start at 3. So basically what this is doing is I can start it at a different number if I want to, but as long as I subtract the other part that I don't want there, and that's going to be equal to the same thing. So I go from 1 to 7, what I'm really looking for is 3 to 7, but I can do 1 to 7 as long as I subtract that 1 to 2. So that's all that is saying.